Welcome to this chemistry tutorial, where we'll learn how to balance redox reactions using the half-reaction method. Redox reactions involve the transfer of electrons, with one species being oxidized and another being reduced. Let's go through a step-by-step process for balancing any redox reaction. We'll use the half-reaction method, which works in both acidic and basic solutions. Here are the main steps we'll follow. Let's work through an example to see how this method works in practice. We'll balance the reaction between permanganate ions and iron 2 plus ions. Step 1. Write the skeleton equation. We start with the unbalanced reaction. In our example, we have permanganate MnO4- plus iron 2 plus going to manganese 2 plus iron 3 plus. Step 2. Split the reaction into oxidation and reduction half reactions. We need to identify which species is being oxidized and which is being reduced. In this case, iron 2 plus is being oxidized to iron 3 plus because it's losing an electron, and permanganate MnO4- is being reduced to manganese 2 plus because it's gaining electrons. Step 3. Balance all atoms except hydrogen and oxygen. Let's check each half reaction. For the iron half reaction, we have one iron atom on each side, so it's already balanced. For the manganese half reaction, we have one manganese atom on each side, so manganese is balanced. But we have 4 oxygen atoms on the left and none on the right, which we'll address in the next step. Step 4. Balance oxygen atoms by adding water molecules. In the reduction half reaction, we have 4 oxygen atoms on the left side and none on the right. To balance this, we add 4 water molecules to the right side. Now, we have 4 oxygen atoms on both sides of the equation. Step 5. Balance hydrogen atoms by adding hydrogen ions. In our reduction half reaction, we now have 8 hydrogen atoms on the right side from the 4 water molecules. To balance this, we need to add 8 hydrogen ions to the left side. Now the hydrogen is balanced with 8 hydrogen atoms on each side. Step 6. Balance the charge in each half reaction by adding electrons. Let's start with the reduction half reaction. On the left side, we have 8 H plus ions with a charge of +8 and 1 MnO4- ion with a charge of -1, giving a total charge of +7. On the right side, we have 1 manganese 2 plus ion with a charge of +2 and 4 water molecules with no charge, giving a total of +2. To balance the charge, we need to add 5 electrons to the left side. This will reduce the left side charge from +7 to +2, matching the right side. Now for the oxidation half reaction. On the left side, we have 1 iron 2 plus ion with a charge of +2. On the right side, we have 1 iron 3 plus ion with a charge of +3. To balance this, we need to add 1 electron to the right side, making the total charge on the right side +2, which matches the left side. Step 7. Equalize the number of electrons transferred in both half reactions. In the reduction half reaction, 5 electrons are consumed. In the oxidation half reaction, 1 electron is produced. To equalize these, we need to multiply the oxidation half reaction by 5, so it produces 5 electrons. Now, we have 5 iron 2 plus going to 5 iron 3 plus 5 electrons. Step 8. Add the half reactions together and cancel the electrons. Let's add our balanced half reactions. Now, we can cancel the 5 electrons that appear on both sides. After canceling the electrons, we get our balanced equation. 8H plus MnO4- plus 5 iron 2 plus yields manganese 2 plus 4 water molecules plus 5 iron 3 plus. Step 9 is optional and only needed if the reaction occurs in a basic solution. If we're in a basic solution, we need to neutralize the hydrogen ions. For each H plus ion, we would add 1 OH- ion to both sides of the equation. For example, if we add 8 OH- ions to each side of our equation, the hydrogen ions on the left would form water, and we'd need to adjust the equation accordingly. But since our example is in an acidic solution, we'll skip this step and go with our final equation from step 8.